Hi, Jim Berthold here from OLI Systems with another video installment on how to use the OLI software. This particular demonstration is about how to find equilibrium constants used by the OLI software. And we do report them, so we can go ahead and try some cases here. So I'm just going to head and add a stream here, and I'm going to switch to the MSC model here, and I'm just going to add some components. I'm going to start off with NaCl, HCl, and CO2. Okay, I'm actually using the OLI tag names here, so let's go back to formula names, just something else you can see here. Just makes it look a little more convenient. We'll put in some compositions here, 1 mol and very light amounts of the other species. We're going to add a calculation, a single point, and we're going ahead and just calculate this. All right, and it's done. So we can find the equilibrium constants in two ways. The first way we're going to do is click on the Output tab here, and then I'm right-clicking to select the sections. And you can see that we have K values, and the little flyout here says either X-based or M-based. What this means is if it's X-based, it's mole fraction-based concentration scale, or molal-based concentration scale. So I'm actually going to pick molal-based because I think that way, but you can pick either one and go ahead and click it. So you can see that we have all of the species here. So this is the species, in this case, carbon dioxide neutral, CO2AQ, and the corresponding equilibrium that is stored in our data banks. The one I point out here is the one for the water dissociation equation here. Here it is on this line here. Now that's water dissociating in essentially hydrogen ion, hydroxide ion. And the equilibrium constant is about 1 times 10 to the minus 14th at 25 degrees in 1 atmosphere. And that's a number that we are very useful, or remember from our freshman chemistry days. We have all of them here are KSPs. It's a little hard to see what that is here. The screen is not wide enough here, and so forth. I could also look for them if I click in the right space, sections, and we'll bring it up. I could also look at X-based, and they'll be in the same thing. So if you look again at the water equation here, if I can find it, it sometimes looks like it wanders away sometimes. Here it is again. Oh, that's the M-based. We'll close that. And then we'll come back down to X-based. Here they are. And here's the water. And you can see that it's significantly different. We actually have a guide and tell you how to convert these. That's available on our wiki page. But the mole fraction-based and molal-based concentration scales are offset. So therefore, they're offset essentially by the amount of water that's present in the system. And there's a conversion factor here. There's an easier way to do this. If you go into the report here, we're going to customize our report. Okay. And I'm going to go on and click on the species K values here. And then we'll click OK. And then I can jump to that section in the report. And I can see, again, in the water dissociation here on this line here. And I can see both the X and M-based at the same time. Okay, that just about concludes the demonstration. All of these variables, by the way, are also available through the plot routines. So we'll just finish that up here. We'll do a survey. We'll just do it very quickly over temperature. We'll just run it very quickly. When you go into the plot, we have these variables, and I'm going to get rid of all of the variables. And down here we have the K values. I'm just going to pick the water dissociation variable, and you can plot it here as a function of temperature. And the View Data button here allows you to see it in tabular format. All right, if you have any questions, please contact us via the portal at portal.olisystems.com to log your support requests, and we'll take care of it as soon as we can. Thank you.